So right now what I'm going to do is talk you guys through this practice section here. So we have a bunch of problems with vertical angles, complementary angles, supplementary angles, and really just applying the angle or special angles we talked about before. So let's look at number one. In number one, we have a diagram pictured below with two lines intersecting at a point. So they intersect here at point N. So then it gives us a algebraic expression for angle JNL and angle MNK as I pictured or wrote down in the diagram. Based off of what we were given, those two angles are congruent because they are vertical angles. So as you see the work here, all I did was set those two equal to each other and solve. Now we have to pay attention to what the question is asking us to solve for. This one wanted just X. So when we solved, we finished off with X. You have to pay attention because sometimes it might make you plug back in to find the measurement for an angle. So same goes for number two. We have labels for vertical angles here, which is the same situation as number one. We are setting them equal to each other because they are congruent. So the only difference here is we solved for X when we set them equal. So 4X minus 40 equal to X plus 50. We solved and got X equals 30. Now we have to find angle AEC. So angle AEC was this angle right here. Now when we do that, we plug 30 in. We do 4 times 30 minus 40, and we get the measurement is 80 degrees. So once again, pay attention to what we have to find. So sometimes it might just say to find the missing variable, and other times it might say to take that variable and plug it in to find a missing angle. For number three, we now have that DEF is the complement of PQR, and then we're given algebraic expressions for these angles. So if they are complements of each other, that means when we add them, both of them together equal 90 degrees. So what we do is we add the measurement for one of the angles plus the other angle. So 4x minus 16 plus 2x plus 10. And then when we go and do that, we solve set equal to 90, and we got that x was equal to 16. So then, once again, we have to solve for angle DEF. We take that and then we plug right back into angle DEF, which was 2x plus 10. And when we do that, we get our answer is 42 degrees. Number four. Angle T and angle R are complementary. If angle T is 4x and angle R is 2x, find the measure of angle R. So same concept here. We take those two algebraic expressions and we add them together and set it equal to 90 degrees. When we do that, you see the work here, we get x equals 15. Now we take that, plug back in for angle R. Angle R was equal to 2x. So 2 times 15, angle R is equal to 30 degrees. We're going to skip number 5 because the diagram was cut off. Now, number 6, angle ABD and CBD are supplementary. So supplementary means we are setting them equal to 180 degrees when we add them. So if angle ABD is 6x minus 12 and CBD is x plus 31, first thing we do to solve for the missing variable x is add them. So we added 6x minus 12 and x plus 31 and set it equal to 180 degrees because it's supplementary. So when we do that and solve, we get x is equal to 23. Then we plug back in to angle ABD, and that gives us 6x minus 12. So 6 times 23 minus 12 is 126 degrees as labeled down here. Now moving on to number 7. Number 7, we're again faced with two angles that are supplementary. So angle A is equal to x, which expression represents the number of degrees in angle B. So this one's a little bit trickier just because we have to model an expression. We're not given an actual degree measure as an answer. So angle A and angle B are supplementary. So when we add them, angle A plus angle B equals 180. We were given that angle A is equal to x. So x plus angle B equals 180. We don't have any information on angle B yet, but if we're trying to isolate it to solve, we would have to subtract x. So if I subtract x from both sides, we get that angle B is equal to 180 minus x. For number 8, same kind of thing here. We're not given an actual measurement as an answer. We have to model it. So if an angle has a measure of 3x minus 10, then its complement has a measure of one of these expressions. So 3x minus 10 is a measure, let's say, of angle 1. So we're talking about two angles here. So angle 1 is equal to 3x minus 10, Angle 2 is what we're trying to solve for. So that means because they're complements, we're doing angle 1 plus angle 2 equals 90 degrees. Angle 1 we said was equal to 3x minus 10, and we're adding angle 2 to that to equal 90 degrees. So now let's try to get angle 2 by itself. So first thing I do is add my 10, then subtract 3x, and when I do that and get angle 2 by itself, we get angle 2 is equal to 100 minus 3x. Let's move on to number 9. So number 9 says we have a bisector. So BD bisects angle CBE, and then we're given a measurement for angle CBD. So angle CBD is 5x. And then angle CBE is equal to 8x plus 16. So the entire angle here, this whole thing is 8x plus 16. So we're looking for angle ABC. So this is a multi-part question here, a little bit trickier. So the first thing we have to do is we have to realize that 5x and 5x are congruent because the angle is bisected. So they are the same exact thing. So if we add those two together, if we add 5x and 5x, it should give us our entire angle 8x plus 16. So when I do that, set them equal, 5x plus 5x equals 8x plus 16, I get x is equal to 8. So all I did was set these two angles added together equal to the entire angle. So now I got x equals 8. So now what do? We have to realize that this is consecutive angles along a straight line. So the total is 180 degrees. So that means this angle plus this angle plus this angle should equal 180. So now that I solved for x, I found that this is equal to 40 because 8 times 5 is 40. So 40 degrees and 40 degrees. So now this missing angle we have to make up to get to 180. So 40 plus angle ABC, we get that ABC is equal to 100 degrees. Number 10, another multi-part question. So we have another bisector here, and we're given measures for one of the angle, actually both of the angles here. So angle ABD was x plus 40, and angle CBD was 3x minus 20. So if I go ahead and I add those two angles together, I should get the entire angle. We know that the bisector means that they're equal. So when I take those two and set them equal to each other, I should get a variable for x. So when I do that, x plus 40 equals 3x minus 20, I get x equals 30. Now, it's asking for the measure of angle ABC, so the entire angle here. So what I have to do is I have to plug into both here and here, make sure they're equal, and then add them together. So when I plug in 30, x equals 30 to both of those, I get 70 and 70. So that means the two of them added together give us angle ABC is 140 degrees. So now let's take a look at number 11. So number 11, we have two perpendicular lines meeting, MA and AT. So when they meet, that forms a right angle. So we're looking for angle HAT. So we're looking for this angle here. So if I change my color, this angle there, 3x minus 5. So what do? Given that they're perpendicular, we know that all three angles added together equal 90 degrees. So if I add 3x minus 5, 2x plus 2, and 3x plus 5, that should allow me to solve for the missing variable x. When we do that, we get 11. And now I have to remember to plug back in that missing angle there into that algebraic expression. So we do 3 times 11 minus 5, as you see up here, and we get that angle HAT is 28 degrees. So now we're on to number 12. So if I clean this up a little bit, we have a bunch of intersecting lines here, but we're given some information. So we're given 3 lines intersecting at point O. We're told that CD is perpendicular to EF. So CD would be this line here, and EF would be this line here. So perpendicular lines form right angles. So that means all of these are right angles. That's going to help us. First, we need to realize that this angle here is 32 degrees, which we're given. We know this angle now, and that's because they're vertical angles. So we filled in something that's going to help us. We also, since we labeled they're perpendicular, have this 90-degree angle here. So we're looking for angle AOF. AOF. This entire angle here. So this red angle is what we're looking for. So now I have 32, 90, and then X here. So I need to combine this X and 90 to help me get to what I need. But I also need this 32 because we have 3 angles or 3 consecutive angles along a straight line. So they're going to add to 180. So that's what I do here. I take 32, 90 plus X and set it equal to 180, and then I get X is equal to 58 degrees. So now I have this angle here. Finally, we're looking for this angle here. So 58 plus 90, that gives me 148 degrees. So that was a multi-step problem there. Now on to 13. For number 13, we have a straight angle. So right away, you should be thinking 180 degrees total. And then it says that they're in the ratio of 1 to 2 to 3. So that means they are multiplied by the same factor in this ratio. So some number X we're looking for is going to help us find these. So what I do is I add an X onto them because they're ratios. 1X, 2X, and 3X combined together gives me 180. And when I do that, I get X equal to 30. I'm looking for angle DBE. So DBE is this angle here. 2 times 30 is 60. I get 60 degrees. 14. We have another straight line. Immediately we think 180 degrees. So line BOC, or sorry, angle BOC is 20 degrees. So BOC is this angle right here. Angle DOA is X, and DOC is 2X plus 7. So find angle DOB. So DOB is this angle and this angle together. So really what we're going to need to do is solve for the variable first. So if I add all 3 of those angles together and set them equal to 180, I get that X is equal to 151 when I solve. So plug in 51, this angle here, and this angle here. So when I do that, I get 2X plus 7 plus 20 degrees. So plug in that 51. 2 times 51 plus 7 plus 20 gives me 129. So plug the 51 in here. That's where we need it. And then add 20 to it, and that gives us that angle. Moving on to number 15, we have 2 lines intersecting at a point. So we have line PQ and RS intersecting at point T. So we have vertical angles created here. Now we're given measurements for PTR and QTS as you see labeled in the picture. So the only thing that I could really do right now is solve to find the variable for X based off of them being vertical angles. So if I set them equal to each other, down here, I set 2X plus 15 equal to 4X plus 1, and when I solve, I get X equals 7. So now how do I use that? Well, if I'm looking for this angle here, there's only one thing that can really help me out, and that's the fact that I'm dealing with a straight line here. So that should tell me that these 2 angles together are 180 degrees. So if I plug that 7 back in to angle RTP, so 2X plus 15, I get that this angle is 29 degrees. So now what I have to do is see what this angle plus this angle being 180 is to solve. So to solve for angle RTQ, I do angle PTR. So this angle here plus this angle here, set it equal to 180, and then I solve. So when I do that, I get that angle RTQ is 151 degrees. Now on to 16. In this figure, we have 2 intersecting lines again. So we have angles 3 and angle 2 with our algebraic expressions. So angle 3 is 8x minus 46, and angle 2 is 10x minus 8 as labeled in the picture. So find the number of degrees in angle 4. So we're looking for this angle here. So now we have to use our 2 algebraic expressions first to solve for the missing variable. We can't get anywhere else until we do that. So here they aren't congruent. We have 2 angles along a straight line again. So we have to go ahead and add angle 3 and angle 2. So 8x minus 46 plus 10x minus 8, and set it equal to 180 as I did over here. So when I do that and solve, I get x is equal to 13. So that's not a degree measurement, that 13. That's just our missing variable. So I don't have an algebraic expression for number 4, or angle 4. What I have to do is I have to plug into the opposite angle because they're vertical angles. So I plug that 13 back into 8x minus 46. And when I do that, I get angle 4 is equal to 58 degrees because we got 58 here, and this angle is congruent. Number 17. Number 17, we have an angle bisector. So ray RT bisects angle QRS. So if angle QRS equals 10x and SRT equals 3x plus 30, what is the measurement of angle QRS? So bisector means that we have two congruent angles created based off of that bisector. So if this one's 3x plus 30, angle SRT, that would be this one here, then this one would have to be the same thing as well. So they're both 3x plus 30. So when we do that, we have a measurement for the entire angle. The entire angle, so these two put together, was 10x. So that means if I add 3x plus 30 and 3x plus 30, set that equal to 10x, I should get my missing variable. So I do that here. I add those together and set it equal to the entire angle. I solve and I get x equals 15. Now I'm looking for angle QRS, so I have to make sure I'm plugging back into the right place. Angle QRS was 10x. So I take that, plug in, and I get angle QRS was 150 degrees. Now the last one, we have another bisector. So we have ray BD bisecting angle ABC. So as soon as you hear bisect, you should think two congruent angles. So if angle ABD can be represented by 3a plus 10, and angle DBC can be represented by 5a minus 6, what is angle ABC? So let's label our picture first. So 3a plus 10 is for angle ABD. So we label that here. DBC is 5a minus 6, so that's this angle here. 5a minus 6. So how do I find angle ABC? Well, the first thing I have to do is set these equal to each other because I don't know the measurement for the entire angle, but what I do know is that a bisector creates two congruent angles. So I set 3a plus 10 equal to 5a minus 6, and when I do that, I get a equals 8. So what do I do with that a equals 8? I have to plug it back into both of them. Plug in 8 to both of these. So I have to plug in 8 for 3a plus 10. So I have to do 3 times 8 plus 10. That's how I get 34 here. And then I have to do 5a. So 5 times 8 minus 6. That's how I get 34 there. And then I add them two together. And I get 68 degrees. We're looking for the entire angle, so we have to make sure we add them together.